Welcome to The Explainer. We're all about taking complex topics and breaking them down into clear, dynamic presentations that just make sense.
So, have you ever really stopped to think about it? What actually happens when you type a website in and hit enter? It just feels like magic, right? But it's not. It's this incredibly fast, perfectly choreographed dance of technology. And today we're going to pull back that curtain and see exactly how it all works in just a fraction of a second.
We're going to trace the entire journey of a single web request. We'll start right from that simple action of hitting enter and follow it all the way to see how your computer finds exactly what you're looking for, even if it's on a server halfway across the planet.
Okay, so where does this all kick off? Well, the very first problem our browser has to solve is a translation issue. You see, we humans, we love easy-to-remember names like Google.com, but computers, they don't get that at all. They only understand numbers, very specific numerical addresses.
And that's where something called DNS, the Domain Name Service, comes in. You can think of it as the internet's giant shared address book. It's just like how you might know your friend's name, but to actually get to their house, your GPS needs the street address. DNS does exactly that for the internet.
So yeah, the main takeaway here is that DNS is the essential translator between us and the machines. Honestly, without it, the internet as we know it just wouldn't work. I mean, can you imagine having to memorize long strings of numbers for every single website you visit? No way. It'd be impossible.
And this right here is a perfect example. On the left, you've got the human-friendly name, google.com, nice and easy. On the right, the machine-friendly IP address, 8.8.8.8. DNS is the magic that bridges that gap, turning the name we know into the number the computer needs to do its job.
All right, so DNS gave us the number. We have the address, but our journey's not quite over yet. Think of it this way. We've found the right street, but now we need to find the specific building and then the right door inside that building. That numerical address we got from DNS is called an IP address. And yeah, the best analogy is that it's a unique street address for a specific server, a building, somewhere on the huge map of the internet. It's what allows our request to navigate through all the traffic and land on the exact right machine.
But here's the next puzzle. We've found the right building, the server. But that server isn't just doing one thing. It's a powerhouse. It could be running a website, an email service, maybe a database, all at the same time. So how does our little web request know which application it's supposed to talk to?
Well, that's where ports come into play. A port is basically like an apartment number for that server building. Each application listens on its own unique port number. This makes sure our request doesn't just show up at the main entrance, but gets routed to the exact door for the service we need, which in our case is the web server.
And what's really cool is how standardized these ports are. Just look at this table. Port 22 is almost always for secure remote logins. And for web traffic, your browser just knows to knock on door number 80 for standard websites or door 443 for secure ones. They're basically the universal front doors for the web.
Okay, let's recap where we are. We found the right server using the IP address. We found the right door using the port number. We're there. Now what? Well, now we actually have to start a conversation. And like any good conversation, both sides need to be speaking the same language.
For the web, that language is called HTTP, the Hypertext Transfer Protocol. It's basically the set of rules, the grammar, for how browsers and servers talk to each other. It defines everything, like how a browser says, hey, can I get that web page? And how the server should respond with all the data. And the best part is, you don't have to worry about any of this. Your web browser acts like this super smart assistant, handling all these HTTP conversations for you behind the scenes. Every single time you click a link, it's firing off these requests automatically, which is what makes the web feel so seamless.
Okay, so all that theory is great, but seeing it in action is way more fun, right? So let's do that. We're going to actually pull back the curtain and become the browser. We're going to open up a terminal on our computer and do these steps ourselves, manually.
First up, we're going to use a command called ping. It's a really simple but powerful tool that's perfect for our first step. Basically, you ping a website and your computer sends out a tiny little signal, like a sonar ping. If it gets a signal back, you know the server's online and it'll also tell you its IP address.
So here we go. We type ping google.com. And look at that. The very first thing you see in the output,
right there in the parentheses, is an IP address, 142.250.191.174. Boom! That's proof that DNS did its job. It took the name google.com and found the number.
All right, ping was cool, but now let's take it a step further with another command, curl. With curl, we're not just checking if the server is there. We're actually going to knock on its door, port 80 by default, and speak its language, HTTP, to ask for the contents of the web page.
And check it out. What we get back is all this code. This is the raw HTML of the website. You can even see the H1 tag in there that says example domain. This is exactly what your browser gets. The browser's only job is to take all this text and turn it into the pretty visual web page we're all used to seeing.
So let's just quickly tie all of this together. We've traced the whole journey from one simple keystroke all the way to getting a web page back on our screen. It seems like a lot, but this process is the absolute foundation for everything we do online.
So you have these 4 key steps, right? DNS translates the name to a number, the IP address finds the computer, the port finds the application, and HTTP is the language they use to talk. That's it. DNS, IP, port, and HTTP. Those are the fundamental building blocks. If you get those, you really get how the internet works at its core.
You know, we just traced a single one of these requests, but just imagine, there are billions of these journeys happening all over the world every single second. So now that you understand this foundation, what are you going to build with it? Because next time you hit that enter key, it's not going to feel like magic. You'll know exactly what's happening behind the scenes. Thanks for watching.